Okay, welcome to WASA Distance Education. This is MBF3C, grade 11 college prep math. And I'm Pete, and I'm your teacher. So we're midway through our short week here, week 3. And yesterday we were looking at the simple interest formula. So that's I equals PRT. And it was a good way to start exploring the concept of interest. But banks and credit card companies and pretty much everyone else actually uses something called compound interest, which is just a little more complicated than simple interest. Now, you're going to need a scientific calculator for this. You're going to need to be able to calculate exponents. So make sure you have a scientific calculator. A lot of smartphones, if you start the calculator on it and then you tilt it in landscape mode, it'll turn into a scientific calculator. I know the iPhone does that. Okay. So let's take a look here. So this is lesson 7, and remember this is in unit 2. Okay, so not your unit 1 handout is the unit 2 course material that you should have. Okay, and if not, you'll have to see your DEC. Okay. So here we go. So this is compound interest, and they actually show you the formula there. Now, the term compounding means that we calculate the interest, and then that interest is added to the principal, and then it's used for the next period, which is called a compounding period. So that's really the way compound interest works. It's if let's say you're compounding monthly, then at the very end of the month they calculate all the interest you've earned or the interest it's owing on the principal, and then add that to the principal, and then in the next compounding period, the original principal plus the interest is used in the calculation for the new amount of interest. So in that sense, the amount of interest compounds, or the amount of money that you're dealing with compounds. Okay, if you owe money, it's it makes it more expensive, but it's a really great way to save money using compounding interest, where you basically reinvest your interest and add it to the principal for the next period of time. Okay. Now the formula for compound interest, there's a couple of different formulas, and I just want to point out this is a really important concept. For simple interest, it was I equals P R T. Now we're on page 9 of unit 2. Now notice that for simple interest, all right, notice that we're calculating the interest, the I. But for compound interest, we're calculating the A, the amount, which is the principal plus the interest. For simple interest, we had A equals P plus I, and that formula actually still applies to compound interest, which means that when we calculate compound interest, we're given the amount. That's what the formula we use gives us. But we can always calculate the interest if we know the principal, right? We just subtract, right? We can say I equals A minus P. We just rearrange the that second formula that we have. Okay. So let's take a look at the compound interest formula. It's A equals P times 1 plus I to the power n. Okay. Now A is the amount of the investment, so we know what that is. So that's the principal plus the interest. P is the original principal, so either the amount of the investment or the amount of the loan if you're borrowing money. If it's a credit card, it'll be your new balance on your credit card that starts with the monthly, the monthly amount you owe. Now this is going to be kind of, so the I is the interest rate as a decimal, so we do the same thing we did before, per compounding period, okay? Per compounding period. So this is where things get a little tricky, because if our compounding period is, say, monthly, then we're going to have to divide that, and we're given our yearly interest rate, and we're going to have to divide that by, say, the number of months in a year. If it's weekly, by the number of weeks in a year. So you'll see that the I will very often be a fraction with the interest rate on top, and then the number of compounding periods per year as the denominator. And then N, it's the number of compounding periods total, which is very easily calculated. Usually it's the number of compounding periods per year times the number of years. So for example, if it's monthly compounding for 2 years, then it's 2 times 12. There's 12 months in a year. 2 times 12 is 24 compounding periods. Okay, if it's 6 months, then it's just 6 compounding periods if it's monthly, right? So N is the number of compounding periods. Now, needless to say, probably the biggest challenge of answering these types of questions is to get the I and the N right, but you're going to have lots and lots of practice in the unit. So, you know, I'm sure that you'll be able to do it. Now, if we are doing compounding periods, it's important to be really kind of on top of how many of a certain, you know, day, month, quarter, whatever, are in a year. So this little chart, you should really have as either committed to memory, or if I were you, you could take a picture of it and keep it in your smartphone, and then you'd have it ready to go. So annually, if something's compounded annually, which you almost never have, one compounding period per year. Semi-annually, that's twice per year. Quarterly, oops, there are 4 quarters in a year. Sorry about that. Monthly, of course, there's 12. Weekly, there's 52 weeks in a year. And then daily, for the purposes of this course, it's 365 days in a year. So what you do is when it tells you what the compounding frequency is, then you're going to know which unit you're going to use if you have to, for example, divide the interest rate. Okay. So the first thing then we're going to look at on, I think it's going to be example 1. It starts at the bottom of page 9, but the actual problems I think the actual problems are on the top of page 10 of unit 2. So sorry about that. It's just a little bit of an awkward page break there. So let's take a look at what the instructions say that we're supposed to do. It says determine the interest I and the number of compounding periods N for each scenario. Don't solve. Okay, so don't solve, which in fact I'm going to encourage you to not solve them. To put them in the formula as a fraction and then wait until you have the whole formula written out. Okay, and so let's see some practice here. So example 1A, top of page not page 10. Okay, just check and see who we got. So what do we have? A principal, so that's our P, of $400 invested at 5%, 0.05. Now that's, we were calling it R, right, in our last, when we were looking at simple interest, but now it's actually part of our I, but it's not the whole I. Let's work it out. Compounded semi-annually, that's 2 per year for 6 years. Okay. So how are we going to work this out? Well, what I'm going to do is I'm going to start a new page here because, and you can follow along right on the top of page 10 here. So this is support, no, this is example. This is example 1, and this is part A. So remember that it's A equals P times 1 plus I to the power N. We need to know our P, we need to know our I, we need to know our N. Okay, so our P, we got that right in the question. It's $400. All right, now our I, the definition of I, I'm going to switch to blue here, is the annual interest rate per compounding period. Now there's 2 compounding periods. So per year. So we're going to have 2 as our denominator, and then the decimal equivalent of the interest rate is going to be our numerator. So it's 0.05, which that comes from the 5%, divided by 2 because there's 2 compounding periods per year. So this is the interest rate per compounding period. Okay, since there's only 2 per year, then it's half of the amount it would be per year. Okay, Now, n is maybe a little easier to work out. There's two compounding periods per year, and it's for 6 years. Okay, so there's 12 compounding periods total, 2 per year for 6 years, and that's usually the way I write it out. Well, it looks like we have everything we need to solve this problem. So let's take a look at solving the problem. Okay, so A equals P, which is 400 times 1 plus I. Now, I recommend that you write your I as a fraction, just like that, to the power n, which is going to be 12. If you write it like that, then no matter what happens after this step, if you've got your I and your n correct, then you're going to get some marks. And it also makes it easier to fix if you later find out that you had a problem with the calculating. Okay. Now, I'm going to tell you how I go about calculating this. Because of this fraction over here, I actually do that part first. Then I do this part here. Then I do that part. And then I do the multiplication. Okay, so it's a little bit backwards, but it works out. It keeps you from having to re-enter numbers in your calculator. Big source of error. If you calculate 0.05 divided by 2, you're going to get some number with a lot of zeros in it. And if you have to type that back in your calculator, there's a good chance you're going to have one too many zeros or not enough or something like that. Plus, it's kind of boring to be typing numbers into your calculator. So here's what I do. For step one then, so it's 0.05. 0.05 divided by 2 gives me a number. It's on my calculator. I got 0.25. Then step 2, I'm going to add 1. So I just say plus 1. So now I've actually got what's inside the brackets. I have 1.025. Now I'm going to do step 3 here, which is taking what I have and just pressing the power button, the exponent button. So exponent 12 equals, and now I have a number. So I can actually cross that one out. So I can actually put down now my intermediate value here. It's 1.34488. It's a big number. Now, the more accurate you are with these, the better. So I would suggest you don't even have to put that down. Just go ahead and multiply that result that you have already in your calculator by the principal, which is step 4 here. And here's what we got. We got 537 point. Now we're going to say 96. We're going to round it off. Now the first thing you want to do, remember we're following the 4-step problem solving model. And the step 4 of that 4-step problem solving model is looking back, reflecting. By the way, these are written out somewhere in your study guide. Somewhere in there, there's the 4 steps. And you can always look them up online if you want some more information. But anyway, so this is what we have. And so the first thing I'm going to do is say, does that seem reasonable? We started with a $400 investment, 5% after 6 years. Does $537 seem reasonable? That does seem reasonable. You know, it's not way out, right? It's not millions of dollars. So you know, it could be reasonable. Okay. Oh, and I think I just didn't do what they said. It says to calculate the I and the N. That's all. Oops, sorry about that. All right, well, did we get the I and the N right? Yeah, it looks like we did. Okay. So, all right, well, I guess I wasn't following the instructions either. Let's extend the page here. So let's take a look at the second one then. I think we're only supposed to do the I and the N. So B says a principal of $625. $625 is invested at 5%. Oh, no, invested at 8.3% compounded weekly for 10 years. Okay, so there's our I and there's our N. Okay, so compounded weekly, there's 52 weeks in a year, and it's 8.3%, 0.083. You can just take 8.3 and divide it by 100. Just because I can do it just like that, it's just because I do this all the time, right? So don't, if you need to use your calculator to get the right answer there, please do. Okay, there's lots of those calculations that I use my calculator for that other people just, do it in their head. Okay, we all have different abilities, and it's your rather your um, mental math ability, which some people have it really good and some people don't. Okay, so we have our I, so it's 0.8083 divided by 52, that's it. And our N, now what's it say? It says compounded weekly for 10 years. So there's 52 weeks in a year, and it's 10 years. So there's 520 compounding periods in this. Okay. Now you could go ahead and work that out, but the instructions said, I think the instructions said do not solve. So I guess I don't want to be naughty here and go ahead and solve it like I did in that first one. All right. I'll just change colors here. So question C now. It says $185 GIC, so that's going to be P is $185. Now, GIC stands for Guaranteed Investment Certificate, and that's if you had $185 doesn't seem like the sort of thing you'd use in a GIC, but maybe. But typically, if you had say $250 or $500, let's say you get your tax check back, and maybe you get your get some money back, and you're not going to need that money for at least 3 months or a year or 6 months or some fairly long period of time, you can put it in a GIC. And what that'll do is it'll give you some money back, and it'll at the end of the term it'll give you some pretty good rate of return. One of the things that some people do as part of their savings, and I did this at one time, I don't now, but I did at one time, where I had every 3 months I had a GIC expiring, and then if I didn't need the money, I would just reinvest it in a new GIC. And so the result is that every 3 months you have maybe $1,000 available to you if you need it, and if not, then you just reinvest it. So it's but it takes a while to get to that stage, right? You don't start with $1,000 to in investment. You start with $50, and you save it, and then you get 100. So here we go. So for question C then, so there's your GIC. It's $185, and it pays 6.75%. So our interest, so 6.75%. Okay, so 3 divided by 4 is 0.75. So it's going to be 6.75%. Okay. It's useful to memorize those if you don't. The 1/2 is 0.5, and then 3/4 is 0.75. It's useful to memorize those fractions, those common fractions for interest rates and things like that. Okay. Now we also have to turn this into a decimal number. Okay, so now we're ready to use it. And remember that our I is the interest rate in decimal divided by the number of compounding periods per year. So let's take a look at it. It says compounded quarterly. Well, if we look at our table on page 9, quarterly, there's 4 compounds per year. So that's what we're going to use. Okay. And I suggest you just leave it like that, because if you take that rather small number, the 0.0675, and divide it by 4, you're going to have a really tiny number. And it's going to be, it's a lot of writing to do. And it's less clear. This is pretty clear because I see the interest rate on top and I see the number of compounds per year on the bottom. Now for N, it's the number of compounds per year times the number of years of the investment. 7.5 years. Well, yeah, we can use 7.5. Nothing wrong with that. Okay, so 4 times 7.5. Okay. Okay, and that's going to be 30. That's how many compounding periods there are in that. Okay, I always do it that way. It's the number of compounds per year times the number of years. If it's 1 year, then it's just the number of compounds per year. Okay. All right. So that was example 1, and I think we're pretty well um, on the way there. It just takes a little bit of practice to do these questions. So, if you're having problems with them, what I suggest you do the sample questions, do the uh, support questions, check your answers in the back, and if you're still having problems with them, I can give you some more questions to do. I can look over your work and sort of help you narrow down where your issues are. Okay, it's just really, these are just a matter of practice. Okay, getting the I and getting the N correct, and then being able to work that out on your calculator, the interest rate formula. All right, so let's take a look at example 2 in the middle of page 10. So it says Josie, Jose, Josie. All right, let's call it, let's say Josie. We don't know, right? You'd kind of have to ask in that case. Josie invested $1,250 at 5.75% compounded annually for 8 years. A, determine the amount when the investment matures. So that's our formula. A equals P times 1 plus I to the power N. How much interest does the investment earn? So that's I equals A minus P. That's the interest rate formula, just kind of, or the amount formula just kind of moved around a little bit. Now, by the way, this is, I sort of am doing steps 1 and 2 of the 4-step problem solving model kind of all at once. Because step 1 of the 4-step problem solving model is understand the problem. Okay, so part of that involves underlining the key points, right? Part 2 of the 4-step problem solving model is devise a plan. Okay, this is my plan over here. Okay, that's step 2 is devise a plan to solve the problem. Okay, and then step 3 is implement the plan. So that's what we're going to do now. Okay, well, they actually have the answer there, but yeah, I'm going to just start a fresh page here, and I'll just show it to you my way, and maybe it'll match what they show. Okay, so we have our principal is $1,250. Okay, our interest and our N, so the interest is 5.75%, so that's 0.0575 divided by compounded annually. Oh, okay, well, so really we could have just skipped that and just said 5.575. There we go. And our N, number of compounding periods per year is 1, so it's 1 times 8, which is 8. Okay. So there we go. That's how we're going to do that. Now, the next step is to work out the amount. I'm going to switch to blue. So A equals P times 1 plus I to the power N. Our principal is 1250. 1 plus 0.0575. Make sure that looks like a 0, not a 6. And then that's to the power 8. Okay, well, this is fairly straightforward to work out on your calculator. So it's just 1 plus 0.0575, okay, to the power 8. And I'm just going to put the intermediate result here. You don't really have to do that, but it sort of helps you to see what should be in the bracket. It's not a big number. It's a little more than 1. It should always be more than 1. Okay. Because what it's doing is you're applying that number to the principal to find out what the principal plus the interest, the amount, is going to be after the end of the investment. Okay, and I got 195503. I'll just round that off. Okay, and that's going to be dollars. Okay. So that's our A amount. Now it also says for part B that we're supposed to work out the I'm just going to scroll back up here. I'll just do part B over here. Just now for part B, they want to know the interest, right? We know that A equals P plus I. So we can just turn that around and say that I equals A minus P. And we have both of those numbers on the right-hand side. So we can say that I is equal to A, which is going to be 1955 3 $1,955.03 minus our 1250. I almost ran out of room there. Okay. 195503 minus 1250 equals, oh, let's try that again. $705.03. Okay, so there is our, let's see here. I want to, okay. So I hope that that made sense. Okay, now this is a word problem, so we really have to kind of answer in words, right? So, you know, the investment earned Josie's investment. Wow, that's pretty bad. It's worth 195503, just something like that. And then for B, it's going to be Josie earns $705.03 in interest. Okay, so that's how you get full marks for a question like that. Okay. So now let's take a look at example 3. I won't necessarily work that out here, but we can actually take a look at it. Oops, can we? Okay, there we go. So example 3 on page 11, it says Claire invested $500 at 4.5% compounded monthly. Okay, so that's a 12 per year for 3 years. What is the amount of the investment at maturity? Now, maturity just means when it's finished, when it's over. What typically happens with a bank is that you basically, it's a contract, right? You're going to put your money in for, you know, in this case, 4.5%, $500. That's a pretty typical investment for 3 years. So about maybe a month, maybe 2 months before the 3 years are up, you'll get a note from your bank and it'll say, hey, your investment's about to mature. What would you like us to do with it? Right? And like sometimes you're on online banking, you can actually go in and click on some buttons and say what to do with it. Put it in your bank account, put it in your checking account, put it in your savings account, reinvest it, right? Right? Or, you know, do something else. Okay, so very often that's what they'll do for you. They'll actually warn you that it's about to mature, meaning that the contract's expired. You're going to get your money, your principal and your interest, and you know, if you want to reinvest it, they usually give you some favorable rates. I know my bank was doing that at one time. They'd give you a little bit extra interest if you just reinvested it straight away. Okay, so because they, you know, otherwise you take that money and go to a different bank and invest it with them. So they want to keep you as a customer. So so that's what the maturity is, and it just means the investment's mature. Now, you may ask, you may wonder, what happens if you need the money sooner? And it really all depends on the type of investment, right? The GIC, it depends on your contract. Generally speaking, at the very best you can do is just get your capital, your principal back, right? Halfway through the 3 years, you suddenly need that $500. Maybe they'll give you your $500 back, but you won't get any of the interest. In the worst case, in some of these investments, you can't get your money back until it matures. So that's where you got to really read the contract and make sure you understand what you're investing in. Okay, this is for money that you're sure you're not going to need for the period of time that you contract. And generally, the longer the period that you invest it, the better your rate. And generally, the more locked in your money is, the better your rate. So the highest interest rates are the ones where you're going to give your money to the bank for a couple of years and you're not going to see it no matter what. Okay, but it can still be a good deal. All right. Now, okay, so let's take a look at this. So the solution for this, so we want to know what is the amount of the investment. So we have our principal. All right, the 4.5% is converted to a decimal, 0.045. And it divided by, it's compounded monthly, so that's why we divided by 12 right here. Okay, that means monthly. Now, they calculate the n exactly the same way I do it. It's the number of compounds per year, which in this case is 12 because it's monthly, times the number of years, which is 3. And then we work that out, and it's 36 months, or 36 compounding periods, which is our n. Okay. Now they can plug all that into the formula. Oh, wow, I like the way this example shows exactly how I prefer to do it. Some of them do it differently. Maybe this particular example is kind of the way I like to do it. So you crank that through your calculator, and then you get the amount. Now remember, that includes the principal there. Okay. So if somebody wanted to know, well, how much interest did you earn? It's that amount minus the $500 of the original investment. So, you probably look at that and figure out that it's $72.12. So it's not a huge amount of money for 3 years, but you know what? It's $72.12 you didn't have before, right? And if you think about it, this is the way people make money through investing, right? If you keep doing that, every time you get $500, you put it in one of these investments, then after a period of time, every month, you'll be getting your $500 back plus the $72. You reinvest the $500, and then the $72 is yours to spend. And what big investors do is they have a bigger pool of money, and they're getting all this interest coming in all the time, and that's how they pay their bills. Okay. So that's now. So that's the compound interest, and we're actually going to do you're going to be using that formula all throughout the rest of the course, because we're going to look at different types of investments and different things like buying vehicles and things like that. So we're going to be using that quite a bit. But let's talk about this other idea, which is the type of growth that an exponential function, which has a variable. Notice it's an exponential function, right? It has a variable. If we go back up to the middle of this page 11, is it? Middle of page 11, notice it has a variable, n, as the exponent. And that is the very definition of an exponential function. Okay. And so they talk about exponential growth here in the middle of page 11. And it says exponential growth is represented by an equation with an exponent, and the graph will form an upward exponential curve. Let's just kind of draw that out. There you go. There's an upward exponential curve. You notice that it's curvy, right? It's curvy, and it's going up very rapidly. Okay. If you watch science fiction movies, zombie attacks, or some plague or something like that, you'll see that they like to show these exponential graphs. Today, this is today we're right here, and then tomorrow that's the number of zombies we're going to have, and then 2 days from now we're going to have 10 times more zombies. That's that's where we get that. But that's actually unconstrained growth of anything. That's what happens. So it's not too far-fetched anyway. So here's an example here. So a principal of $100 is invested at 8%, compounded annually, so that's once per year for 6 years. Okay. Now, typically, in this course, they will tell you whether it's simple or compound interest. In this case, they just skip that, but we're in the compound interest formula, the compound interest section. So we can just assume that they want compound interest. Okay. So create a table of values to show the amount of the investment at the end of each year. Graph the relationship is the growth of the investment. Linear. Explain. Okay. So we can make a table of values, and we're going to, oh, okay, now use the compound interest formula to determine the amount for each year. Okay. So we're gonna do that. Now, typically, if you were to do that, and if you look at page 12, they have it right there. Okay. In the book, all of the different values, right? But let's say that we wanted to make our own table and not have to calculate it by hand. I'm just going to show you that if you go to Excel, Microsoft Excel, it's a spreadsheet program, okay, and it's pretty straightforward to actually use Excel to make a table like that. It may seem like it's complicated, but really, you could learn to do it. There are all sorts of oops, all right. I just got to get out of that pen tool. There are all sorts of videos out there. If you go to Microsoft's website and you say Excel training or learn Excel or something like that, it'll give you some free videos on how to use it. But anyway, you just you type the year, right? Year, and this you can type anything, but we're just making a table, right? And so the year and the amount in dollars. Okay, so I'm just showing you how to do this because they give you the table in the text. So why don't we just see here about making our own table? So the year, they want a year 0, 1. Now I want to show you something here because you could type all those, but if I wanted 20 years, well, then it would be kind of ugly, right? So what I do is I'm going to select both of those. And all I did was I clicked in the first one and I held my mouse button down and I dragged. Now when you go to this little handle, see the little black handle right here? If I go to my little black handle and I pull, notice it's going to increase the count for me. You see? It's because Excel knows that you probably want to make a table. If you put 0, 1, probably going to make a table. And by the way, if you wanted to count by 2s or 5s, it's pretty smart. It'll actually figure that out. So our original amount is $100. Or yeah. And what I'm going to do, I'm going to select all these cells, and I'm going to do format cells. And we want number. Actually, we want currency. That's what we want. So I just clicked currency there, and I said OK. And notice it shows it as $100 now, right? So what I want to do for the second formula for year 1 is I want to enter the formula. Now the way Excel has a formula, you press the equal. Oops, you press the equal sign, and that tells Excel when you start with an equal sign that you are entering a formula. Now, what we're going to do is we're going to click on the $100, which enters, it refers to whatever is in that cell. So if later we want to try $500, we can just change the 0 cell, the one where it has 100, we change it to 5, and it'll change everything below. So now in Excel, the time symbol is an asterisk, which is 8. It's shift 8. Okay. You have to use that time symbol. It's an asterisk. It's pretty common that computers need an asterisk for multiplication or times. They can't use an X. So now we're going to open a bracket, and we're going to say 1 plus, and now our interest rate, we're just going to type our interest rate in at 0.08. Okay. And in Excel and in a lot of computers, they use an up arrow, which is shift 6 for your exponential function. Okay. Now, in our case, we want to pick the year. We want to use the year as our exponential function. So I just click on that cell. And the reason it puts an A3 in there is you'll see that this is an A and this is a 3. So each cell actually has a column and a row. It's kind of like playing bingo, right? This is column A3. Okay. So now if I hit enter there, you notice it's going to calculate it for me, right? And there it is. It's $108. Perfect, right? Well, if all I was going to do was just you have to type all that in. Well, it would be easier just to type in the actual answer, isn't it? But here's the cool thing about this. If I hit the copy button and then I select a whole bunch of cells and then I hit the paste button, notice it fills it in for me. What did I do wrong here? All right. Well, let me see what I did. Okay, B7. Oh, I see what I've done. Okay. So, you know, I'm going to have to go back a little bit. I'm going to edit this. You see where I said B2 there? It's not so easy. I'm just going to put the 100 in there. Otherwise, it just makes things complicated. So now I'm going to copy, and now I'm going to paste them down here. There you go. That's better. Okay. So unfortunately, well, if we need to change the formula, we'll have to change it. But we'll just change it up here and then paste it again. Okay. So the nice thing about that is, let's say that I wanted to know what 10 years would look like, right? I can just drag this down. Whoops. I can just copy this one and just paste it in there, right? And it'll just keep going for me. The other nice thing about Excel is that if you select the titles plus your data and you go to the insert menu and you want a scatter chart with smooth curves, you can just do that, you see? And it shows you your curve. Now, this is not real clear that it's exponential, and one of the things that, oops, sometimes you have to do is you have to format your axes. Oops, all right, so uh, format, I'm looking for the select data. What I'm looking for is it's pretty good. I think it's the axes. No, properties, no. All right, well, I'm having my problems finding it. Select data. No, that isn't it. There's actually a button that you can press to basically, because right now it starts at 0, but we want it to start at 100. That would give us a better chart. But for some reason, I can't find it right now. Huh. I don't know why. Well, this could be a different version of Excel. And oh, okay, maybe this is it. Ah, there it is. Okay. So what I did was I clicked on the actual. I clicked on this data here, and it actually gives you. Well, okay, now it's not. It was. There we go. So you see the axis on axis options, the minimum. Well, we want the minimum to be $100, and you see that the maximum. Let's make it $220. Okay, so now the curve will be there. You go. So the curve's a lot better now. It kind of shows you how to right that you can do that, and you can see that it's an exponential curve. It's even clearer if you kind of drag it. Oops, if you drag it out and make it a little, should be a little clearer. Okay. So that's how you do this. It's you know, a little bit of sometimes trial and error, but if you actually go on the Microsoft website, they will show you how to do that. And it actually makes a fairly decent graph. There's a few things like it didn't label the bottom here in years or label this in as amount. That you should probably do that. But you know, it's a good handy tool if you're trying to make a graph, and if you have to make a big long table here, right? It's a pretty useful thing. Let's see if we can get it to give us a few extra values. Look at that. It gave us a few extra values, right? And then, I don't know, we have to change our chart to include it. But there you go. And you see it changed our chart for us. Okay. One of the issues I have, you see it went above because I changed the maximum. So now I have to change the maximum to say 300 to 320. So, you know, when I changed it to manual, it that's one of the things I gave up was it automatically updating for me. So there you are. So if you had to do a table like that, that's probably something you could do. And you know, if you're asked to make a table and you want to do that in Excel, you can just print it off and send it in. It's no problem at all. Now, the thing that they want you to see here in the course material is that the first differences for these entries are different. Now, the first difference is you just take one number, um, actually like that. So let's say I'm going to take 100, 108 minus 100. So the difference is 8 right there. 116, just got to move that a little bit. So 116 minus 108, 116, 64 minus 108. And of course you could do this in Excel too. You notice it's 864. So we're actually calculating the difference between the lines, and sort of typically you write it right on the line, like the line between them, you write it there. But you know, like in if you were doing that in Word and you're making a table, it would be pretty hard to get it lined up. So you can put it just above or just below, and most usually just below. So 125.97 minus 11664, and then my difference is, you see that not only is the differences, they're not the same, but they're increasing as we go up the table. Okay, so those first differences, okay, are an example of exponential growth, a nonlinear. Okay, sec here, make sure everything's good. Okay, so those are nonlinear growth graphs. Okay, when the differences are not all the same. So if you were to calculate it and the differences were all the same number, okay, and usually it's enough to calculate 3 and then you know, okay, then that would be linear. So if they're all the same, it's linear, and if they're different, it doesn't really matter if they're going up or down, but if they're different, it's exponential growth. So you may be asked to do that in a key question, maybe in a final exam, okay, and this is what they've done here. You know, what is the difference between those two numbers? And you see in this chart, they really didn't have a place to put the numbers right between them, so they kind of put them down one, which is fair enough. Okay, so since the differences are not constant, the growth is not linear, right? Okay, well, not linear, it's exponential. Okay, so here are the support questions, and as usual, you can check your try these and then check the answers at the back. Okay, so the first one, we'll just take a look at the support questions. We've done a few of those. Determine each amount, so that's the A, right? A equals P times 1 plus I to the power n. And that'll really, if you do those, that'll really help you understand whether you're getting those I's and N's correct or not. And you can look at the back there. And you know, if you have problems with any of them, you can always contact me with the information in your study guide, or just wait till the next class and call in, or use the chat function and ask me, or send me an email and say, hey, can you solve this in the next class? I'll be happy to do that. Now, the second one here, so it says Karen purchased a 2,500 compound interest CSB. That's a Canada savings bond. And again, that's a pretty typical thing. Annual rate of 4.25% and a 7-year term. Okay. So one of the things it doesn't say, I'm assuming that it's compounded yearly from the looks of things, because it doesn't actually say otherwise. Okay. And you know, that's what Canada Savings Bond, you buy it, and then you know, every year your interest is added to the principal, and then it's reinvested at the same annual rate, or at whatever annual rate. One of the things about Canada Savings Bonds is that they usually are adjusted. So you might buy the 4.25% one, but if interest rates go up, the government doesn't want you to cash them in, so they'll increase the interest rate for the following year. Quite often they'll do that. Okay. All right, and finally 3. So principal is invested at 3 3/4 or 3.75 compounded annually for 5 years. Okay, draw a graph to show the amount of the investment at the end of each year. Okay, so you're going to need a table to go with that as well. Is the growth of the investment linear? Okay, explain. Now explain would be showing the differences. Or you can refer to the graph and you can say, well, it's not a straight line. The points don't lie on a straight line. Okay, that's what they mean by explain. Okay, I know that those word problems can sometimes be a little bit challenging. Okay, and there's your key questions. Now, in this particular, let's have a look here. Yeah, so your key questions would be pretty much the same thing as we were doing here. For question 3, you're choosing between one that's compounded annually, which is a slightly higher interest rate, and one that's compounded quarterly with a slightly lower interest rate. Okay, and that's the sort of life um, um, skill that this type of math will give you, right? GIC for 2 years, and you got to choose between 2 different plans. This might be at 2 different banks. It might be two different plans that are offered by your bank. They won't necessarily tell you, or even if they do tell you at the bank which is better, you want to work it out yourself. Okay, so you can easily do that. Um, okay, so there we are. All right, well, I think we better probably wrap that up for now. So go ahead and try those key questions. Make sure that you're working on your key questions and sending them in. Don't wait to get a whole bunch of them. Just send them in as you do them, and that way I'll get them back to you that much faster. All right, well, thanks for joining us today, and we will see you tomorrow.